Hello, I am Dr. Bob. I am going to show you how to install and set up the Yuasa U-shaped folding test jig FS. There are two versions of the FS. On the right is the Fs-C. It is an FS with a cartridge. The other version, on the left, is the original FS, which does not have a cartridge, but it can stretch a sample. The Fs-C cannot be used for stretching. That's the basic difference in the two jigs. The Fs-C can flex samples, and it has a cartridge that facilitates removing the sample for microscopic inspection. The FS can flex samples, and it can stretch samples. They look very similar. Perhaps the most obvious difference is the 4 thumb screws sticking up on the Fs-C. The thumb screws are used to lock the cartridge. A second difference, but less obvious, is that the tilt clamps can be lifted off the Fs-C. When you're using the cartridge, this is necessary so you can quickly remove the sample. The tilt clamps cannot be lifted off the FS. They are rigidly attached. That is necessary so they can be used to stretch samples. Another difference is that the corners of the tilting clamps on the Fs-C are almost square. The FS corners are cut off. When looking at drawings, for example, or close-up photos, sometimes it is hard to determine which version you are looking at. The square corners have been one of the keys for me. And one other difference. The vertical guiding walls on the Fs-C are not as tall as they are on the FS. The first portion of this video will show the installation of the Fs-C and motor drive unit. Then the Fs-C will be set up for U-shaped folding, and then the FS will be set up for stretching. I'm going to show you how to install and set up the Yuasa U-shaped folding tester Fs-C. I will be using the motor drive unit DLDM111LH. The setup will be similar if you are using the motor drive units DMLHB or DMLHP. We are starting with the two pieces separated, the Fs-C jig and the motor drive unit, as if you have just removed them from their shipping boxes. Place the motor drive unit on the left and the jig on the right. There are only a few tools. First is a T-type hexagon bar wrench. I call it an Allen wrench. It is a 3mm hex wrench. Second is a locking latch that is used to lock the motor drive unit in place when you adjust the cam follower to set the reciprocating distance. The cam follower is inside the adjusting port, which has a cover. Keep the cover on the unit for your safety when operating the machine. These tools should be in the shipping box. I am using also a separate 3mm hex wrench and a crescent wrench. This is the output shaft and the floating joint that will be installed on the motor drive unit. Position the motor drive unit with the adjusting port facing you. The Fs-C should have its cartridge fastened in place on the jig. We will remove the cartridge during the installation by loosening these 4 thumb screws and sliding the cartridge out. Set the cartridge to the side. You will use it later in the setup with a sample. Lock the 4 thumb screws back in place so you don't lose them. This is the moving slider. The jig should be positioned with the moving slider on the left. This is the fixed slider. The fixed slider should be locked in place on the far right using these 2 screws, one on the front and one on the back. They should be fastened with 3 Nm of torque, which is about 2.2 foot-pounds. Virtually all adjustments will be set with 3 Nm of torque, except for the cam follower, which will be 3.5 to 4.0 Nm or 2.6 to 3.0 foot-pounds. Make sure the motor drive unit power switch located on the left side is turned off and the motor drive unit is not plugged in. The output shaft should be installed if it is not already installed on the motor drive unit. Attach the floating joint to the output shaft with 9 Newton meters of torque, that is 6.6 foot-pounds. The floating joint, which holds the moving slider to the output shaft, should be installed before we attach the jig to the motor drive unit. Attach the combined shaft to the motor drive unit with 9 Newton meters of torque. There are 2 screws that will securely fasten the 2 units. They may already be attached to the frame of the jig on the left side at the bottom. Remove them if they are installed. To attach the jig to the motor drive unit, first push the output shaft into the motor drive unit to minimize its interference with the jig. Then lift the jig and slip the left side of the jig, the moving slider side, into the joint bracket on the right side of the motor drive unit. Lift just the right side of the jig, the fixed slider side, and position the floating joint into the slot on the bottom of the moving slider. Install the 2 screws to securely fasten the units. Tighten them with 3 Newton meters of torque. The jig is now fully attached to the motor drive unit, so you can begin the setup for testing. I need to give you a strong caution at this point. The jig may have been set for a test by somebody else, and you do not know the settings. You do not know what the reciprocating distance is, or what the folding radius is. The reciprocating distance determines how far the moving slider will move to the left and right of its midpoint. The folding radius determines the position of the fixed slider from the far right end. The tilt controllers will be set for that previous situation. If you make the reciprocating distance greater, the tilt controllers will be too short. The motor will pull the moving slider to the left. The moving slider will want to stop when the tilt controllers are fully extended, but the motor will keep pulling the moving slider to the left farther than the tilt controllers allow, and you could damage the tilt controllers. Before you change the reciprocating distance, you must first loosen the tilt controllers on the fixed slider. These are the tilt controllers. I loosened them about 1 revolution. Now the tilt controllers are loose. And loosen the fixed slider setting screws. I am loosening each of them about 1 revolution. Now the fixed slider is loose. Note also that the tilt controllers will always be all the way to their end on the moving slider. You will not be changing that. Only the fixed slider end is adjusted. There will be slack only on the fixed slider end. Let's remove the adjusting port cover so we can take a look inside. You can use the T-type hex wrench to remove the top 2 screws. Loosen the bottom 2 screws. Lift the cover and set it to the side. Now we will plug in the motor drive unit. And turn on the power switch. Let's take a look at the touch panel on top of the motor drive unit. This is the touch panel. Note also the large red emergency stop switch. We will look at the touch panel in more detail later, but first note the jog button. You tap the jog button to make the motor move only a short distance. You press and hold it to make the motor continue to move. Tap it, hold it. Let's do that again looking at the jig. I'm holding the jog button, I'm tapping it, tapping it, tapping it, tap again. Now I'm holding it. Let me do it one more time while looking inside the adjusting port. I'm tapping the jog button. Now I am holding the jog button. While we are looking in the adjusting port, let's see how we adjust the reciprocating distance. We have to use the jog button to line up the mechanism a certain way. There are two locking holes. The two locking holes must line up exactly before you can push the locking latch into the holes to lock the cam follower into one position so you can adjust it. You can use the jog button to move the two holes into close alignment. It is probably best to turn off the machine now because you are locking down the motor. You may have to slightly rock the moving slider to push the locking latch into the holes. Now the cam follower is locked. This is the cam follower. This is the scale. The reciprocating distance is currently set to 40 millimeters. We will change that to 20 millimeters. Turn the cam follower counterclockwise about 90 degrees to loosen it. Keep the hex wrench in the cam follower because the cam follower could fall when it is loose and get damaged. Do not turn the cam follower more than 90 degrees because it could come apart. Move the cam follower using the hex wrench until the cam follower is centered on 20 millimeters on the scale. Tighten the cam follower to 3.5 to 4 Newton meters or 2.6 to 3.0 foot-pounds. Remove the locking latch. Now you can turn the machine on. Now the reciprocating distance is set to plus and minus 20 millimeters. Let's go back to the touch panel. There are only a few controls we will use in the setup. The home button, the count button, the speed button, and the start-stop button. Tap the count button and you will be able to set or reset the number of reciprocations you want. Touch the number for target. You can set the target number with the touchpad. Let's set the target to 12. Press 1 and 2 and enter. To reset the count, hold Reset. Press the home button to go back to the main screen. Tap Speed to set the reciprocations per minute. Tap the number presently showing and set the new number. Let's choose 30 reciprocations per minute. Tap 3 and 0 and enter. Let me point out that the Fs-C has a maximum allowable reciprocation rate, and that is 90 reciprocations per minute. Press the home button to go back to home. To run the test, press Start-Stop. You are given a confirmation button to actually start. Tap the green Start button. Now the machine is running. The count is updating. The machine will stop when it reaches the target number. Maybe you want to examine the sample during the test. Let's stop the machine. Touch Stop. Now you can remove the sample. Loosen the 4 thumb screws. Move the moving slider to the end on the left to make it easier to insert the cartridge. Slide the cartridge onto the jig. Tighten the thumb screws. Lift the cartridge. Now you can examine the sample, perhaps under a microscope. These 4 posts align the tilt clamps with the jig. We have finished the examination. Let's put the sample back on the machine. Align the tilt clamps with the posts. Loosen the thumb screws. Slip the cartridge from under the thumb screws. Tighten the thumb screws. Now we can resume the test. On the touch panel, press Start Stop. Confirm with the green Start button. Now the test resumes where it was when we stopped to examine the sample. Let's try the emergency stop. Press it. The machine stops immediately. The touch panel shows the emergency stop button was used. Press Home, and you'll see the emergency stop button is lit and it is red. Take care of whatever the issue was when you applied the emergency stop. To undo the emergency stop, turn the emergency slip clockwise, then recycle the machine by turning it off and on. There are 3 different methods you can use to calculate the reciprocating distance. I will call them Case A, and Case B, and Case C. You need to decide what the folding radius you want to use before setting the reciprocating distance. Case A may be the simplest and can be used if the folding radius is less than or equal to 12 millimeters and the sample length is less than 90 millimeters. Case B can be used for any sample as long as you can clamp or tape the sample to the tilt clamp. The folding radius must be 22 millimeters or less. Case C, similar to Case B, is a special case when you have a sample with an area that you cannot clamp or tape to the tilt clamp. As in Case B, the folding radius must be 22 millimeters or less. In Case A, the sample length must be less than 90 millimeters and the folding radius must be less than or equal to 12 millimeters. We calculate the sample length to be 56 millimeters plus 2 times the whole folding radius plus the holding distance on the moving slider plus the holding distance on the fixed slider. Or sample length equals 56 plus 2r plus A1 plus A2. Let's use a folding radius of 7.5 millimeters and set the holding space on each end to be 5 millimeters. Then the sample length will be 56 plus 2 times 7.5 plus 5 plus 5, or 81 millimeters. We set the reciprocating distance to be half the calculation, or plus and minus 40 millimeters. The sample length could be longer than 81 millimeters. I have already adjusted the reciprocating distance to be plus and minus 40 millimeters. I will now set the folding radius to be 7.5 millimeters. Here's how we do that. Use the jog button to move the moving slider to the maximum of its movement, the closest it gets to the fixed slider. Then move the fixed slider towards the moving slider until the spacing is 2 times the folding distance of 7.5 millimeters, that is 15 millimeters. Then lock the fixed slider with the 2 screws. Now I'm at 15. Now I lock the fixed slider with the 2 screws. Check it again. It's good. Tighten the far side. Now you need to adjust the tilt controllers. Move the moving slider to its far left end using the jog button. Pull the tilt controller through the fixed slider until it is tight, then tighten the screw. I normally do the front side first. Then the back side. I usually do the front side again because it is easier to set it now, making the tilt clamps horizontal. I have cut a sample that is 85 millimeters long and 50 millimeters wide. I will mount it on the tilt clamp using adhesive tape. I have set the reciprocating speed I want to use on the touch panel. I have set the number of times I want to fold my sample. I have reset the count. Now I can start my test. And the test is complete. In case B, the folding radius must be less than or equal to 22 millimeters. The reciprocating distance is calculated as being more than 0.77 times the folding radius plus 29.23 millimeters and less than 93 millimeters minus 2 times the folding radius. Select a reciprocating distance within that range. Then you calculate the length of the sample. The length will be 2 times the reciprocating distance plus 2 times the folding radius minus 24 millimeters plus the holding distance on the moving slider plus the holding distance on the fixed slider. I will select a folding radius of 12 millimeters and holding spaces of 5 millimeters. The reciprocating distance must be more than 0.77 times 12 plus 29.23 and less than 93 minus 2 times 12. That's between 38.47 millimeters and 69 millimeters. I will select a reciprocating distance of 58 millimeters. The sample length will be 2 times 58 plus 2 times 12 minus 24 plus 5 equals 126 millimeters. My sample is 50 millimeters wide. I have set the machine for a reciprocating distance of 58 millimeters. I have set this fixed slider 2 times the folding radius or 24 millimeters away from the moving slider when it is closest to the fixed slider. I have taped the sample to the tilt clamps so I can begin my test on the Case B sample. Start the test with the Start Top button and confirm with the green Start button. Now this test is complete. In case C, the folding radius must be less than or equal to 22 millimeters. I have a display sample that cannot be clamped within the display area. That length is 85 millimeters. I will select a folding radius of 10 millimeters. The reciprocating distance can be calculated as half the protected length of the sample plus 6 millimeters minus the folding radius. My display sample length is 112 millimeters. The holding spaces are 5 millimeters on each end. The sample width is 81 millimeters. The reciprocating distance will be 0.5 times 112 plus 6 minus 10 equals 52 millimeters. I have set the machine for a reciprocating distance of 52 millimeters. I have set the fixed slider 2 times the folding radius or 20 millimeters away from the moving slider when it is closest to the fixed slider. I have taped the sample to the tilt clamp so I can begin my test on the Case C sample. The target count and the reciprocation speed are already set. I press the Start Stop button and confirm with the green Start button. Now this test is complete. These 3 cases are explained in the instruction manual. I selected my own numbers for this video, not necessarily those illustrated in the instruction manual. Let's prepare the FS for a stretching test. We need to do 3 things to prepare the FS for stretching. We have to remove the tilt controllers, We have to lock down the tilt clamps in the horizontal position, and we have to install the sample clamps. I'm removing the tilt controllers. Now I'm going to lock down the tilt clamps. And now I am installing the sample clamps. When you lock the sample clamps, make sure that you don't make them too tight, otherwise it will bump up in the center and not securely hold the sample. Now I have attached the Fs to the motor drive unit. I did not show the installation because it is exactly the same thing we did with the Fs-C earlier in the video. The motor drive unit I am using for the stretching is the DMLHP. I used the DLDM111LH for the flexing. The DMLHP will allow an extended range of stretching, which I will show you here. I have set up the DMLHP for a plus and minus 15 millimeter reciprocation distance, as if it were a DLDM111LH or DMLHB. With those machines, the reciprocation is set with a mechanical cam and is centered 60 millimeters from the left side of the Fs. You can see that the moving clamp does not reach the left side. It stops 60 millimeters minus 15 millimeters or 45 millimeters before the end. I set minus SP to 45 millimeters and plus SP to 75 millimeters. You can see the Yuasa CS setup video for an explanation of these settings. The DMLHP using a stepping motor can be set up to have the reciprocation begin at the far left side of the Fs. I have changed the setup to show you this. The reciprocation centered 15 millimeters from the left side of the Fs. I set minus SP to 90 millimeters and plus SP to 120 millimeters. You can see that the sample can be much longer with this setup than it can be with the DLDM111LH or DMLHB. This is still a plus and minus 15 millimeter reciprocation distance, but it has been moved all the way to the left side. I will show you the extended range this allows in a slide later in the video. Before we mount a sample, let's look at the parameters involved in stretching. Note first that the maximum stretching the Fs can accommodate is 120 millimeters. The smallest unstretched sample length the Fs can accommodate is 6 millimeters plus the clamping distance. The maximum stretched sample length the Fs can accommodate is 132 millimeters plus the clamping distance. The longest unstretched sample length the Fs can accommodate is 72 millimeters plus the clamping distance with the DMLHB and DLDM111LH. The longest unstretched sample length the Fs can accommodate is 132 millimeters plus the clamping distance with the DMLHP. The maximum allowable stretching force with the DMLHP is 72 newtons or 16 pounds of force. The maximum allowable stretching force with the DLDM111LH and DMLHB is 400 newtons or 90 pounds of force. The maximum stretching percentage capability of the FS is available with the shortest sample. In this case, a 6 mm sample can be stretched to 126 mm or 2000%. As the unstretched sample length increases, the maximum stretching percentage decreases. All these numbers arise from the specifications, mechanical and electrical, of the FS testing machine. During the rest of this video, so I don't have to keep saying plus the clamping distance, most of the time I will not include the clamping distance in the values. Always remember, though, to include the clamping distance in the sample when you prepare one. There are 4 numbers we will be working with: LU, the unstretched sample length; LS, the stretched sample length; S%, stretching percentage, which is LS minus LU divided by LU, or LS over LU minus 1, and RD, reciprocating distance. For stretching, we must specify 2 of these 4 numbers. Often that is the unstretched sample length and the stretching percentage. The equations for determining the other 2 values are then LS equals LU plus LU times S%, and RD equals LU times S% divided by 2. Earlier in this video, when we were setting up the testing machine for flexing, we normally spoke about the reciprocating distance as a plus and minus figure. That's how we set the cam follower. It is the same case here. Recognize, though, that the amount of stretching we will do is the total of the plus and minus reciprocating distance numbers. When using these equations, keep in mind the limits. Maximum RD is plus and minus 60 millimeters. Minimum LU is 6 millimeters. Maximum LU is 72 millimeters. Maximum LS is LU plus 120 millimeters if the sample is less than 12 millimeters. And it's 132 millimeters minus LU if the sample is more than 12 millimeters. I have provided 2 figures for your convenience in determining the reciprocation distance and stretching percentage. Use figure 1 when the stretching percentage is going to be 350% or less. In the figure, the stretching percentage is shown in red, and its value is on the left vertical axis also in red. The reciprocating distance is shown in green, and its value is on the right vertical axis also in green. The horizontal axis is the unstretched sample length. The vertical blue line at LU equals 72 millimeters is the end of the range for the DLDM111LH or DMLHB. All values of LU greater than 72 millimeters can only be done using the DMLHP. That is the DMLHP extended range of testing that I mentioned earlier. Use figure 2 when the stretching is going to be greater than 350%. In this case, I have not shown the extended range of the DMLHP because it is not available at these greater stretching percentages. If you have a specific sample size, find that value on the horizontal axis, unstretched sample length. Go up that black line until you reach the red line to determine the maximum stretching you can achieve with that sample. That value will be on the left axis. Go up or down that black line until you reach the green line to determine the reciprocating distance for maximum stretching. That value will be on the right axis. If you have a specific stretching percentage, find that value in the red left vertical axis. Go across the black line until you reach the red line to determine the unstretched sample length, not counting clamping distance. That value will be on the horizontal axis. Go up or down that black line until you hit the green line to determine the reciprocating distance. In my case, I want to have a stretching percentage of 100%. I can use an unstretched sample length of 66 millimeters, and I want to stretch it to double its size, 132 millimeters or 100%. From the figure, we see that the reciprocating distance will be plus and minus 33 millimeters. I am still using the DMLHP, but I am setting the reciprocating distance as if it were a DLDM111LH or DMLHB to be consistent with the flexing portion of this video. If you want to stretch the sample less than the maximum percentage stretching, use a smaller reciprocating distance. You can use equations to calculate the value. Once you have determined the values for your test, whether using the figures or the equations, you can prepare your sample and set up the Fs Jig and motor drive unit. When making your sample, don't forget to take into account the clamping distance. The steps to set up the Fs Jig and motor drive unit are: first, move the jig's fixed clamp all the way to the end. 2. Set the motor drive reciprocating distance according to the determined value. 3. Use the motor drive's jog to move the moving clamp all the way to the end where it is closest to the fixed clamp. 4. Set the fixed clamp to the position where the distance between the clamping plates is the value unstretched sample length LU, not counting clamping distance. Mount the sample. I am moving the jig's fixed clamp all the way to the end. I have already set the motor drive's reciprocating distance to plus and minus 33 millimeters. I'm holding the jog button on the touch panel to set the moving clamp at the end where it is closest to the fixed clamp. Now I am setting the fixed clamp 33 millimeters away from the moving clamp. I'm tightening the back screw. I'm tightening the front screw. Let me check the distances. Jog the moving slider to the left end. The distance is 66 millimeters. That's correct. Set the moving slider at the right end. The distance is 33 millimeters, and that's correct. The test will be doubling the length of the sample, 100% stretching. I need to remove the sample clamps. I will move the locking screws in closer to the center on each end of each sample clamp. Here's my sample. It's a flexible fabric. So now I will mount the sample. Put the sample clamps back on. And again, do not over-tighten the screws on the sample clamp. It can cause the sample clamp to buckle up in the middle and not hold the sample securely. At this point, we can proceed to conduct our test. I have already set the count to 0. I have set the target count to 10 cycles. I have set the speed to 30 reciprocations per minute. Touch the Start-Stop button on the touch panel and confirm by touching the green Start button. I'm stretching the sample 10 times at 30 stretches per minute. I'm stretching the fabric to twice its size each cycle. And our FS stretching test is complete. This concludes the Yuasa FS setup video.